Hello everyone, today we're going to be working on problem 3-15 and this problem is saying that the unstretched length of spring AB is 3 meters long. If the block is held in the equilibrium position shown, determine the mass of the block at D. So this problem, what's given to us is the three springs and their stiffness. So spring AB, spring AC, and spring AD, and we're trying to solve for the mass of the block at D, and it's given to us some dimensions. We have 3 meters here, 3 meters here, and 4 meters here. So to determine the mass of the block at D, what we're going to do is we're going to determine the forces of each spring to then later determine the mass. So if you guys remember that the force of a spring is equal to the stiffness times delta, and we know that delta is equal to the final length of the spring minus the original length of the spring. And then if we go back to the problem, it gave us that the unstretched length of spring AB is 3 meters long, so that's the original length of the spring. So since they gave us that information for spring AB, we're going to be working off with that spring, and then we're going to use that spring to find the rest of the forces of the other springs. So for spring AB, we know the stiffness, we know the original length, but what's missing is the final length. So to find the final length, we're going to take a look at this image. This image already shows the spring while it's stretched out. So we're trying to find the length of that spring. We know that this side, if we were to look at this like a triangle, we know that this side is 3 meters long, this side is 4 meters long. So to find the hypotenuse of a triangle, we know that that equals to the square root of a squared plus b squared. So that's what we're going to do. So we have length final of AB is equal to the square root of 4 squared plus 3 squared, and that gives us a total of 5 meters long. So we know that the final length of the spring AB is 5 meters long. So now that we have the final length, the original length, and the stiffness, we could find the force for that. So the force for the spring AB is equal to, we know that has a stiffness of 30 newtons over meters. We know that the final length is 5 meters, that the original length is 3 meters. From there, we get 30 newtons over meters, and then from there we get 2 meters. We know that the meters will cross out, so that means that the force of the spring AB is equal to 60 newtons. So now that we were able to find the force of the spring AB, now what we're going to do is we're going to proceed by drawing a free body diagram of the figure that was given to us, just to help us determine the rest of the forces of the other springs. So I already drew it out here. As you could see, we have point A right here. From there, we have the force of the spring AB, which is right here, which we already found out that that force is 60 newtons. Then we have the force of the spring AC right here. And then from there, we have the force of the spring of AB coming down right here within the weight of the mass, with the weight of the block at D. So before continuing on, there is something left for us to do. We need to find the angles right here because they're going to help us later on in the problem. So to find these two angles right here, we're going to take a look at these like as if they were triangles. So if we were to look at this like a triangle right here, and then we're trying to find this angle right here, we know that this side of the triangle is 3 meters long, and then we know that this side of the triangle is also 3 meters long because it's given to us up here. So with correspondence to this angle, we know the opposite side of that angle and the adjacent side of that angle. And if you guys remember, we know that tangent is opposite over adjacent. So if we were to call that angle theta, we know that tangent theta is equal to opposite over adjacent. And if we were to solve that for theta, we know that theta is equal to the tangent inverse of opposite over adjacent, which is just 3 over 3. So that means that that angle will equal to 45 degrees. So the first angle right here equals 45 degrees. Now to find the angle for this triangle right here, once again, we are trying to solve for this angle right here. And once again, we know that this side of the triangle is 3 meters long because we know from this right here. And then we know that this side of the triangle will be 4 meters long. So once again, we could use that tangent theta is equal to opposite over adjacent. But instead of having it 3 over 3, this time we're going to be having that as 3 over 4, since now the adjacent side of that triangle is 4 meters. And if we were to plug that into our calculator, we end up getting tangent inverse of 3 over 4. We get that angle is equal to 36.87 degrees. And just like that, we were able to find the angles of those two triangles, 36.87 degrees. So now that we were able to find those two missing angles that we're going to need, we're going to proceed by finding the forces of spring AC and AD. And to do that, we're going to be breaking down each of those forces into their x and y components, making sure that they're also in equilibrium. So we're going to solve it like this. We know that the sum, that the sum of the forces in the x direction have to equal 0 to be in equilibrium. So we're going to start off with force AB, which we know equals 60 newtons, 60 newtons, since we solved for that earlier on. So we're going to start off with that one. We're working with our x forces, so that means we're trying to find its horizontal component, meaning that anything going to the right is positive, anything going to the left is negative. This is going to the right, so that's going to be a positive force. So F A B, the force of the spring AB times, and then to find the horizontal component to that, once again, if we look at this like a triangle right here, we are trying to find this side of the triangle, and we're working with this side of the triangle. So with correspondence to this angle that we found, we are trying to find the adjacent side of that triangle, and we are working with a hypotenuse side of that triangle. And if you guys remember, cosine is adjacent over hypotenuse. So that means that we could times the force of AB with cosine of the 36.87. So now that we were able to find the first one, now we're going to do the same thing for the force of AC. And we know that that force is going towards the left, which is why that's going to be negative. As you can see, this is going slanted to the left, so that's why it's going to be negative. And now, once again, looking at this like a triangle, we are trying to find this side of the triangle, since this is the x or horizontal side of the triangle, we are also trying to find the force of this side of the triangle. So we're trying to find the force of the adjacent side with correspondence to this angle and the hypotenuse side with correspondence to this angle. So once again, we could use cosine to solve for that. So times cosine of the 45 degrees. And then if we were to look at our force of AD, there is no horizontal component to that since it is completely vertical. So we don't have to do anything to that. So we just have to equal that to 0 now. So if we were to plug in for the force of AB, since we found that earlier, we have 60 newtons times cosine of the 36.87 minus the force of AC times the cosine of the 45 degrees has to equal 0. So if we were to plug that into your calculator, you'd get 60 newtons times cosine of 36.87. Once again, make sure that your calculator is in degrees and not in radians. So cosine of 36.87 times 60 newtons is equal to 47.99. So in a way that just equals 48 newtons minus the force of the spring AC times cosine of 45. That is equal to 0.707. And that has to equal 0. Now from there, what we're going to do is we're going to move the 48 newtons on the other side to be able to solve for our force of spring AC. So we have the negative force of spring AC of 0.707 is equal to negative 48 newtons. And if we were to divide both sides by 0.707, we would get that the force of the spring AC is equal to 67.89 newtons. So now that we were able to find the force of AB, with that we were able to find the force of AC, but now the most important force that we need to know is the force of AD, because we know that the force of AD minus the weight of the block has to equal 0. So we first found force of AB since we started working with that one because there was some information given to us. And by finding the force of AB, we were then able to find the force of AC. And now that we know the force of AC and AB, we can now find the force of AD. So to find the force of AD, we're now going to have to work with our Y components. So we know that the sum of our forces in the Y direction also have to equal 0. Now that we're going to find our forces in the Y directions, the first thing that we could do is we could start off with our force AB. Once again, we are working with our Y components. So anything going upwards is positive, anything pointing downwards is negative. So as you could see, our force of AB is going to be positive. Our force of AC is going to be positive. The only thing negative is going to be our force of the spring AD. So we have once again a positive force of AB, of the spring AB, times, and this time instead of using cosine, we're going to be using sine, because if we were to look at this as a triangle, we are now trying to find the opposite side of this angle right here. And we're still working with this hypotenuse side. So we have opposite over hypotenuse, and that is equal to sine. Sine is equal to opposite over hypotenuse. So we're going to times that by sine of the 36.87. And then from there we have our positive force of AC times, and once again, instead of using cosine, we're going to be using sine because now we're trying to find this force of the triangle right here. Once again, that's the opposite side. We're still working with this hypotenuse side. So once again, we could use sine. So times sine of 45 degrees. And then from there, our force of spring AD is completely vertical. So we don't have to do anything to it. We just know that that force is going to be negative. So we're going to come here and write minus the force of the spring AD has to equal 0. Now that we have that, we can start plugging in our forces. We know that this came out to being 60 newtons times sine of the 36.87 plus we found the force of AC, which we know that that's equal to 67.89. So that will times sine of 45 degrees. And then we could already move the force of AD to the other side. So we know that that is equal to the force of AD. So if we were to plug that into our calculator, get 60 newtons times sine of the 36.87 degrees is equal to 36 newtons plus, and then we have 67.89 newtons times the sine of 45 degrees. That should give you 48.00 newtons, so 48 newtons, and that equals the force of AD. So if we were to add those two things together, add those two forces, we would get that the force of the spring AD is equal to 84 newtons. Now that we were able to find the force of the spring AD, the next step would be remembering that the force, let's work up here. We know that the force of the spring AD minus the weight have to equal 0. So if we were to rewrite that, we know that the weight is the same as the force of the spring AD, and we know what the force of the spring of AD is, which was 84 newtons. So we know that the weight of the block is 84 newtons. But remember, this problem asked us to find the mass of the block and not the weight of the block. So if you guys remember, we know that the weight of anything is equal to the mass times the gravity of it. So we know that the weight is 84 newtons. We're trying to find the mass, and we know that gravity is equal to 9.81. So to find the mass, all that we have to do is divide that 84 newtons by 9.81, giving us that the mass of the block is equal to 8.56 kilograms. And just like that, we were able to determine the mass of the block at point D.